Welcome to Chapter 9, where we will explore how to plan your quantitative data analysis. This chapter will help you match the right statistical techniques to your data types and research questions. We'll cover the most commonly used analysis in social and behavioral research, giving you the knowledge to write a strong analysis section in your research proposal. Today's objectives focus on practical analysis planning. We're not doing mathematical calculations. We're learning to think strategically about data analysis. You will leave this session knowing how to match statistical techniques to your research questions and data types, which is essential for writing credible research proposals. Understanding data types is crucial because it determines which statistical analysis you can use. Nominal data uses words to describe categories like gender or political party. There's no inherent order to these categories. Interval data, however, uses numbers that represent quantities like test scores or income. The numbers have meanings in terms of more or less. This distinction drives all your analysis decisions. Percentages are the workhorse of nominal data analysis. They're easy to understand and compare across groups. But percentages can be misleading without context. If I tell you 33% of Russian majors dropped out, that sounds concerning. But if there were only 3 Russian majors and 1 dropped out, the percentage is less meaningful. Always provide both percentages and the actual numbers they are based on. When you want to explore relationships between nominal variables, contingency tables are your tool. They show how 2 variables relate to each other. But the pattern you see might be due to random sampling variation. The chi-square test helps you determine if the relationship is statistically significant, meaning it's unlikely to be due to chance alone. The null hypothesis is a foundational concept in statistics. It's the assumption that any differences you observe are due to the luck of random sampling rather than the real difference in the population. Statistical tests help you decide whether to reject this null hypothesis. If you're studying entire populations rather than samples, you do not need significance test because there's no sampling error to worry about. For interval data, means and standard deviations work together to describe your data. The mean tells you the typical score, but it doesn't tell you whether everyone scored close to that average or whether scores were spread out widely. Standard deviation fills in that picture. A group with mean equal to 40 and a standard deviation equals 2 is very different from a group with a mean of 40 and a standard deviation of 15, even though they have the same average. When you want to compare group means, your choice depends on how many groups you have. With 2 groups, use a t-test. With more than two groups, use ANOVA. Both tests help you determine if observed differences are statistically significant or just due to random variation. Note that ANOVA tells you if there are significant differences somewhere among your groups, but not which specific pairs of groups differ. Measuring change requires careful analysis planning. You can't just compare post-test scores because groups might have started at different levels. Change scores, post-test minus pre-test, let you see how much each group improved. Then you compare the amount of change between groups using a t-test. This design controls for initial differences and focuses on the treatment effect. Correlation measures how two interval variables relate to each other. A positive correlation means they tend to move in the same direction. Higher math computation scores go with higher word problem scores. A negative correlation means they move in opposite direction. Higher esteem goes with lower anxiety. The closer the correlation is to -1 or +1, the stronger the relationship. Statistical significance is about probability. When we say a result is significant at the 0.05 level, we mean there's only a 5% chance this result could have occurred if the null hypothesis were true. Most researchers use 0.05 as their cutoff. If the probability is 0.05 or lower, they reject the null hypothesis and call the result statistically significant. A result of a p-value less than 0.001 is very strong evidence against the null hypothesis. Choosing the right analysis starts with understanding your data and research questions. First, identify your data type. This immediately narrows your options. Then consider what you're trying to do. Compare groups, examine relationships, or measure change. The number of groups matters for selecting between t-test and ANOVAs. Whether you're using samples or population determines if you need significance test. This systematic approach will help you make good analysis choices. Here are some common mistakes to avoid in analysis planning. Don't choose your analysis method before you understand your data type and research questions. Make sure your test matches the number of groups you're comparing. Remember that significant testing is only needed with samples, not populations. Don't forget basic descriptive statistics, means, percentages, etc. Most importantly, let your research question drive your analysis choice, not the other way around. The analysis section of your proposal should be straightforward and specific. Name the exact statistics you'll compute. If you have multiple research questions, organize your analysis plan accordingly. You do not need to go into computational details, but be specific enough that readers understand your approach. Always mention your significant level if you're doing hypothesis testing. So let's review the essential points. Your data type is the starting point for all analysis decisions. Make sure your statistical tests match what you're trying to do. Comparing two groups requires different tests than comparing multiple groups. Understand that statistical significance is about probability and sampling error. Always plan for basic descriptive statistics along with your hypothesis test. Most importantly, let your research questions drive your analysis choices and communicate your analysis plan clearly in your research proposal. As you develop your research proposal, use this framework to plan your analysis section. Start by clearly identifying what type of data each of your variables will produce. This determines your analysis options. Then match your analysis methods to your specific research questions. Don't forget to plan for basic descriptive statistics that will help researchers understand your data. If you're doing hypothesis testing, specify your significance level. Organize your analysis plan clearly, ideally by research question or hypothesis. Remember, a well-planned analysis section demonstrates you understand how you will answer your research questions with data.